Oh, my stars, here we are again. It's the Fly By the Seat of Your Pants Bird Festival in replacement of the in-person bird festival of the Morro Bay Winter Bird Festival. And we are glad you're here, glad you're joining us. We have an excellent speaker today. It's Dr. Steve Beissenger, and he's going to be talking to us about rails. And who doesn't want to know about rails? Come on. And so we're glad to have him here with us, and I'm looking forward to learning a lot of new things. Now I already know everything there is to know about being an advanced bird photographer and how to do the rehab for birds locally. So now we're up to rails. So can't wait for it. So this is a Zoom meeting, so there's a couple things that are normal Zoom functions that we're going to turn off just to let you know. And one of those is everyone's going to be muted, and that's because if you can't, you got a couple hundred people in a room, you just can't have everybody chit-chatting back and forth because it's a Zoom. Also, there's a raised hand function, and we're not going to use that. We're not going to recognize you, so don't even bother pushing the button because we're just going to ignore it. Now, the chat function really is important because it's the way we'll be able to talk to the presenter and ask him questions. But we're not really going to turn that on until a little bit later in the program. We want you to hear a little bit from him so you can develop a good question and not distract him with the chat button lighting up all through his presentation. So towards the end, we'll open that chat and ask me a question, and I will facilitate those questions with our speaker, okay? Finally, we want to do another bird festival in person. We'd love to do it next year. But because of the cancellation, we're losing a lot of money from vendors that we can't get replaced. So we're looking for donations. All of these Zooms are free, and you can come on and invite all of your friends for free. We'd love that. But if you're able, we'd love to have a donation if you can. Several ways to donate: old-fashioned way with a checkbook and a stamp, and send us a letter. That would work. All the details there are on the Morro Bay Winter Bird Festival website, and you can do that. Or if you want to just click on a link and make a donation, you can do it that way. Go to the Morro Bay Bird Festival website and you can find that link. Or if you're one of those cool kids that knows how to use a phone and has a Venmo account or a PayPal account, as we close, we will put up a screen with the QR codes. You can just hold up your iPhone or your Android phone and scan that code and make a donation that goes directly to the Morro Bay Bird Festival like that. It's amazing. Already this morning, about $1,000 has been raised, and that will really help us put together a festival in the future. So thank you so much for your generosity, if you're able. Okay, now on to the program. Just to let you know, the program is being recorded, and with any luck, we'll have these up posted so you can see them later, or share them with your friends later. The program is being recorded. So this afternoon, our presenter is Steve Beissenger, and he is a professor of ecology and conservation biology at UC Berkeley. His research centers on wildlife responses to global change and species extinction. He directs the Grinnell Research Project, which is a long-term effort to revisit locations throughout California that were first surveyed, in the early 1900s, 100 years ago. And so he's doing that in order to quantify the impacts of climate change and land use on the animals of California, which I think is pretty darn fascinating. Steve has a long data sets on parrotlets in Venezuela, and he's researching secretive threatened rails so we can figure out how birds and people can coexist. He's authored over 200 scientific publications, senior editor of 3 books, fellow of several scientific societies, and received lots of rewards for his research on birds. So you know what, if it's not good, you're just going to have to email him. So anyway, Steve, we are really looking forward to having you and hearing about rails today, especially the black rail. So what do you have to share with us? Let's go.
All right, let's start with the screen. Let's see how that goes. All right, lovely. Looking good?
Yeah. Well,
so.
Well, right now we're seeing your whole screen. I don't know if you work with Bob on this. We're seeing your whole screen, we're seeing your whole laptop.
All right. Now better?
Still seeing your whole screen. Bob, jump in if you've got some recommendations.
All right, we'll try it again here.
Is this a PowerPoint?
Yeah, it's PowerPoint.
Yeah, you got to go to
Here we go.
slideshow.
There we go.
There
Beautiful.
we go. Third time was the charm.
Thanks.
All right, thank you guys. How's your virtual bird list coming today out there? Hoping to maybe give you something to see that you haven't seen before, or at least not often anyway. So I want to talk about conserving the California black rail and how do you save something you can't see? Because if you know rails, you know this is your typical view. You can see that rail in there, can't you? Well, in fact, it's a challenge to study rails. And the black rail is probably our least understood and least known bird in the rail family, and one of the lesser understood birds in North America. One of our most threatened birds in California, as a matter of fact, but you wouldn't know it. If you look at these maps of the range maps for the black rail and the closely related Virginia rail, you can see a real difference in what we do know about their distributions. The Virginia rail is widespread in the northern part of North America, winters down here along the coast and southern ends of North America. The black rail, you've got a lot of question marks over here. And the east coast, it's mostly been known from coastal marshes, but there's something going on in the interior and even in the Midwest. And here in the West, well, we pretty much know this as a coastal species. So big marshes in the San Francisco Bay region. Another location down here along the lower Colorado River. And then this spot over here in the foothills of the Sierras, which was discovered by one of my collaborators, Jerry Tecklin, in 1994 in the Sierra foothills. And most of our research about black rails has taken place there. You'll notice a couple of things going on here. Some X's down here. This is Tijuana Slough estuary wetland. They used to be down here. We have specimens to show it, but no rails in recent decades. Same with Carpinteria Marsh. And over here is where we're supposed to be birding at the moment in Morro Bay. And interestingly, there was a great report done by John Rosser in 2011, work sponsored by the Morro Coast Audubon Society and funded by Morro Bay National Estuary Program to spend a couple of years surveying for black rails in this region. And he didn't find any and did a very thorough set of surveys. These are sightings mostly historic, most of them from the 1970s and 80s, 90s, a few in the early 2000s of where black rails have occurred. And if you've seen a black railish bird and gotten really good looks at it, it's probably not a black rail because they're so secretive. This is the kind of places in San Francisco Bay. They're in these large wetlands within parts of the estuary here. And historically, there was much more tidal marsh than there is now. Interesting processes of restoration of a lot of these tidal marshes is going on, and a concern that sea level rise may become the ultimate problem for these rails in the region. This is what a tidal marsh looks like in San Francisco Bay, or in the estuary where you start to get more brackish water. And here is where we find them in the Sierra foothills. Here's a marsh. It's coming along this side of this hill, coming down here. And this is a working landscape. It's got lots of oaks, it's got lots of pasture, and it's got black rails. The work I'm going to tell you about has been 20 years in the making, 5 dissertations, started all by Jerry Tecklin and myself when Jerry kind of discovered these black rails. And the research of Orion Richmond, Laurie Hall, Nathan Van Schmidt, and Sean Peterson kind of feature in the long-term work that I'll tell you about today. Oh, by the way, not a black rail that Laurie is holding here. That's a yellow rail that she caught in the San Francisco Bay Area. All right, so here's first test. We find rails by going to marshes and playing back their calls and their songs. And the calls should sound like this. Hopefully you're hearing it. At dawn, when you're playing this back, sounds a lot like cookie dough. Cookie dough. But people call it kinky doo. That's one of their main territorial and attraction songs. And they're very, very responsive to the playbacks of this call. And in fact, we can go to marshes and we have a high probability of detecting them if they're there by doing this playback. Don't try this at home. You need a permit to do this from the Fish and Game. Here are some of the kinds of habitats that we found them in the Sierra foothills. They look nothing like the kinds of places where they were occurring in the bay or in the estuary areas along the coast that we talked about previously. Fringes of ponds, this turns out to be not very good habitat. Streams and stream wetlands, slopes where water is running down and continually running down from some source that attracts wetland plants, and even sometimes on the edges of impoundments like this rice field, we found them. Here's one of my favorite spots. This is a complex that starts, the marsh area starts up here at the top of the hill where there's some trees, and there's a well and a natural spring up there, and there's also an irrigation ditch that helps to augment the water coming down here. And it flows down this hillside down to a stream at the bottom. My colleague Jerry's standing here on the edge, and you can see the distinction between the wetland vegetation and the upland vegetation very clearly. So it's going down this hillside, and right under these trees was a Native American acorn grinding spot where they would sit in the rocks and grind acorns with other rocks. And you kind of wonder if they were listening to kinky doos or cookie doughs back then. We've been doing this across a large section of Yuba, Nevada County, a little bit of Butte, and a little bit of Placer. And we've found over 300 sites that we've visited that are small wetlands scattered around, like kind of mini population of wetlands. And we found birds at almost 200 of these sites, off and on over the years. So most of the sites are small, as you might have gotten the impression by looking at the previous pictures. By going back year after year, we can get the proportion of sites that are occupied from one year to the next, and the proportion that go from being occupied to being unoccupied or going extinct in a year. And we can get the proportion of sites that get colonized or had no rails the previous year and now have rails the following year. This population of sites, different sites, we call a metapopulation, kind of scientific term you can walk away with today and amaze your friends at happy hour. Okay, so if you look at this during the first 5 or 6 years of our study, the probability of occupancy that a site that we visited had a rail was pretty high, about 55%, and pretty steady. There was some years with more extinction, some years with more colonization, but overall, it was pretty much a steady state. And then something happened. There was a big extinction event. Colonization dropped to almost nil, and the occupancy of sites decreased by 50% almost. It coincides with the arrival of West Nile virus into our region in California. If you know West Nile virus, it's a mosquito-borne vector that actually their reservoir host is birds. Most of those mosquitoes don't bite people, but sometimes it does leak over into people and other livestock. It had major impacts for a while on corvids, crows and jays, and also a number of raptors. And we hypothesized that this might be one of the causes of the major decline that we saw. Now, something in our region, it kind of arrived and was high in numbers around 2006. So this kind of relates nicely to when we saw this big decline. But of course, also starting around that time, a little later, we started to see droughts, severe droughts. And of course, this is a wetland bird. So we could expect those droughts to have a big impact as well. So we continue monitoring our population, going back to these hundreds of sites every summer, at least 3 visits, so that we can correct these values for any variation in detection probability, because we don't always get a rail when it's there. You can see this trajectory. This population has been kind of going down in its occupancy. And you can kind of think about the proportion of sites occupied as kind of like, well, the health of the population, let's say. Can't take its temperature. We can't count the number of individuals because we never see them. They just respond to our call. And so this graph shows you part of the value of a long-term monitoring program. We can see this trend, and also we see where some of these drought events were most severe. You could also see sometimes a high extinction probability or low colonization probabilities taking place in those years. So when we looked at these data and we tried to ask, well, what is it that's really caused this change? There were 3 things that really did pop up, and when we did our statistical analysis. One was annual precipitation. That turns out to be the strongest driver. These drought years and years of low rainfall definitely push the population down, extinction rate increases, and colonization rate declines. So we can see that that is one of the overall drivers. But West Nile virus came in and kind of added an extra knock to that. And also a third thing, that can be cold temperatures in the winter. So freeze days actually contributes also. So the number of days that are freezing or below in the region can have a negative impact as well. And so these 3 things now have resulted in a large, steady decline of black rails. We don't know if they've reached kind of a new equilibrium down here at about 25% of the sites being occupied, compared to, say, 55 or 60% when we got started. But that's where we find ourselves now. Things, of course, got stopped by COVID as we were doing this work. Okay, West Nile virus. We knew at that point we had to figure out a way to catch rails. How do you catch a rail? There haven't been a lot of good ways invented, so we kind of experimented with the old ones and came up with a new one. We use a mist net in the marsh, and someone hidden over here in the vegetation is playing back the love song or the fight song to the rail, and we try and get the rail to walk into the mist net. It takes some patience, a little bit of luck, but it works. And when it does, there's lots of happy faces. And the effort, it's a good bit of effort to set this up and to make it work with a 4-person crew. So when you get a bird and you capture one, you want to get all the information that you can. Here, we're taking measurements and we're collecting feathers for analysis of its diet that we can get. And we're also taking a blood sample that we can use for genetic studies. So we did this kind of work intensively for 6 years. And you can see the numbers of birds that we caught each year over here. We got ramped up and really going when Laurie Hall took over in 2012 and 2013. And you can also see the proportion of birds that that their blood tested positive for West Nile virus. So clearly West Nile virus was occurring in these populations. We don't know for sure that it was killing the birds. That would take trials in captivity. We captured the birds, we banded them, took our samples, and then released them. But we can show definitively that these rates were important and probably pretty unexpected. So taking the blood samples, we also did some of this work around San Francisco Bay, where there we have to go out at night with some bright lights. And actually we use a hand net to capture the birds. If this sounds like fun instead of hard work, well, you're right. It can be. And the hard work then gets done in the lab. And here's Lori taking blood samples, turning them into DNA. From there, we use genetic markers, and we've learned that black rails in the foothills mostly move short distances. We figured that out because we identified parents and offspring pairs from their genetic signatures, sort of like DNA profiling, and we could match first order relatives. And then we could measure how far away they were in the marshes that we caught them. So most of the movement is really short distance. But there were a few that moved 20 miles, and we had one bird that we banded that moved from the foothills to the delta, the San Francisco Bay, and met a wind turbine. And so was picked up, and we had a band return. And so we also, as a result of that and the genetic information and the isotope information, we know that there's very limited movement of the rails between the foothills and San Francisco Bay, but there's some. And the genetics told us that there's really almost no connectivity between those two populations and the one in Southern California along the Colorado River. Okay. Interestingly, around San Francisco Bay, we expected to see some more genetic structuring, but we didn't. In fact, I was betting my bottom dollar that rails would have to go around the delta to colonize and move between marshes across the bay. That wasn't the case. In fact, the genetic signatures suggested that they could cross the bay. We're doing more work in that area now with more markers as part of a genomic study, and that should help us figure out with much more precision what kind of movements we're seeing. Now, the interesting thing about the rails and these wetlands is that 2/3 of these sites were augmented by irrigation water, and they occurred on private land. That means that private landowners are really the stewards of these birds. So the irrigation ditches are shown here in blue. There's a whole series of them. We like to move water around in California, and this is what a ditch might look like. Doesn't really offer any habitat for the birds, but what does happen is that sometimes the ditches accidentally leak, and the water runs down the hillside and creates a marsh. Or we can take the water out of the marsh in through a pipe and create leaks down the hillside and create a marsh. Here is a pipe section on Spenceville Wildlife Area in Yuba County that's been managed for these wetlands. And you can see the nice wetland vegetation going down the side of this hill. As long as the water keeps very slowly moving down here, this rail that only likes a half inch of water or so to walk around in, half into an inch, is quite happy colonizing the wetlands in these sites. And it's interesting how fast the plants find this water source. And here you can see a sort of marsh being created in transition very new. It's only a year old. You can see some wetland plants in there. You can see some more typical upland plants in there. What you can't see that's there are the rails. So somehow the rails find these marshes. Now, I told you they don't fly very far typically. When you catch one, you let it go, the first thing it does is go straight under into the vegetation, flapping like a butterfly straight down into hiding. Unlike, say, Virginia rails that are also in some of these marshes, and when we catch those and they take off, man, they head for the horizon, someplace farther away. So the black rails, somehow they're getting around. It's like a paradox. How do they get around and get out to these places? And how do rails get out to all these oceanic islands and become flightless? Somehow they are capable of making these longer distance movements. And that made us realize that if we are going to conserve the rails, we needed to understand the landowners who were the stewards of those wetlands. And we had this rather complex system. So we started out being interested in the rails, and figured out after a little while that it was the size and the number and the stability of these wetlands that affected the rails. But then West Nile virus came in, and that was also affecting the rails. And it might have some negative consequences for the landowners as well, who themselves are either irrigating or destroying wetlands, and who themselves gain aesthetic value or recreational value by having these wetlands. Most of our landowners have been very cooperative in letting us come on their land year after year. They've been great. And many of them are just interested to know that they've got this rare bird on their land. But they are responsive, the landowners, to the irrigation districts, who themselves are doling out water based on allocation rules in this region. And their practices then affect the wetlands. And those practices then obviously through the wetlands affect the rails, which as they become rare or more common, become more or less interest to the wildlife agencies like the U.S. Fish and Wildlife Service, or for example, our California Department of Fish and Wildlife. All of these things are context within climatic variation and climate change, and also the land use around these sites. So it's what has become to be known in the parlance as a coupled human natural system. And you can see this web of interactions is going to be important for the rails and sustaining them. And so working then through a next set of studies with colleagues who were sociologists and hydrologists and disease ecologists, we were able to uncover a lot about these connections, about the values and attitudes of landowners towards their water and towards their wetlands, and about their concerns or lack of concerns, as it mostly turns out to be, about threats from West Nile virus. So this has helped us to figure out, in a way, how to conserve the black rails at the sort of bottom of this web of interactions. All right, let me transition. Some of you may know or be aware that a little over a year ago, the eastern subspecies of black rail, that one that we were looking at that seems to be mostly coastal with lots of question marks at the beginning, that was listed under the Endangered Species Act as threatened. The California black rail was not included in that listing, even though it's probably as rare or rarer than in other parts of the range. But I think that's actually a good thing, because there's some wonderful landowner cooperation already going on that's helping to boost the rails in California. Interestingly, there's so little known about the rails elsewhere. Most of the information at the time of the listing was sort of based on old information about habitat loss, sea level rise, and museum specimens or old sightings of where species had been. The first real surveys got going on the East Coast after the arrival of West Nile virus. And so that wasn't even on their radar. Neither was the idea that they could create habitat using irrigated water like we have. And so our population has become a really useful model to provide information for how to think about recovering the East Coast birds. And so now there's a big effort going on to try and create what they call emergency habitat near tidal marshes that the birds might be able to occupy using the same methods that we've been using here in California. So kind of coming through and around to the first question of where I got started. How do you conserve a bird you can't see? I mean, look, we go out, we do 500 or 600 surveys a summer, and we see the birds 5 or 6 times, literally. So you have to find some other creative ways to think about coming up with measures of the health of a bird population. We can't count on citizen science to help us out with this one because citizens are dying to get, oftentimes, to get the black rail on their life list. And the best way that many people have found to do that is to go to some of the big San Francisco Bay wetlands during king tides, when the water gets deeper and it kind of pushes the rails to leave their vegetative cover to sort of seek other spots where they'd be able to get out of the deeper inundation. So we couldn't do that. We started with some very basics, and the very basics were habitat. And we could learn something about habitat and the things that were attractive to the rails there. We could use the habitat and the habitat changes and the long-term monitoring to kind of get at that. It was only then that we were able to go from getting our feet wet to actually getting our hands on the birds to be able to learn more about them through different ways that scientists like to gain inference from, from feathers, from blood, from measures of their health and things that we could get. So all of this has given us what I guess you could call a view of the railosphere. And you have to be lucky. You have to really have a good imagination to think about something like that, because you don't get to see them very often. It's just hit or miss. And that's exactly what's happened through most of the time in our studies. Fortunately, we've had more hits than misses. And I would say that we couldn't have done this work without a lot of cooperation from the private landowners that let us come on their land every year, that let us do the surveys, that have given us permission to use this information. We are based out of the Sierra Foothills Research and Extension Center. That's a UC property in Yuba County, just downslope from Grass Valley off of Highway 20. That's dedicated to learning about the effects of natural resource management on species, and also for managing for grazing stock as well. We've had a lot of Berkeley undergrads and summer techs have worked with us, been part of that devoted field crew, gained training, went on for graduate studies or to careers in consulting or agencies, and funding from the National Science Foundation especially, and also 2 chapters of the National Audubon Society, among them the Sierra Foothills and Sacramento Valley chapter, and especially Sierra Foothills. They have been a tremendous booster for our work. They've helped us to get started, and we're really obliged to them for all the help that we have received. So with that, I think I'd like to kind of wrap up this speed talk and leave some time, Chris, for questions of various kinds and discussion.
Oh, holy smoke, Steve. I've been sitting here for 45 minutes and I just feel a lot smarter just by sitting here. And so thank you very much. That was really fascinating.
You're
Okay.
welcome.
I don't want to be, cruel or mean, but here's the deal. It's a small little bird nobody sees or nobody. Why in the world should we care about this? And why don't we just let it go?
Why in the world should we care about it?
Yeah, why should we? The title is Conserving the Black Rail. Why? That's my question. Why?
Conserving the black rail, why? Well, it's a good question. It's interesting, and I mean, I think it's probably true for a lot of species. You could say, well, it has a unique role in its ecosystem. Yeah, kind of. It's an indicator of a certain kind of ecosystem. Yeah, definitely. So in the Bay Area, for example, in Morro Bay, for example, it's probably a good indicator of the kinds of very shallow water wetlands that that would have occurred there and have mostly disappeared from that region. Now it's also an indicator to some degree of where West Nile virus might be a bit of an issue for us. But it's very specialized, and probably like many things, it's there's human values behind it. I can't tell you how often I'm regularly asked how I'm going to see one by a birder.
Well,
I'm sure that all 106 participants are in here right now saying, where am I going to get it on my life list, Steve?
Yeah, all we really wanted to know from this thing is, where do we see one, right?
Exactly.
By the way, there's a rumor that the last black rail in Morro Bay may have been eaten by a great blue heron or great egret. Is there any reason to refute that? My friend Marlon Harms has a photo of a great egret eating a Nelson Sporo that's also very uncommon in Morro Bay. Talk to me about that.
Well, so Morro Bay is interesting. And there's not a lot of habitat there right now. I think that could change. But there's definitely, when the tides get high here in the bay, and there's king tides, people do see great blue herons, gray white egrets, others eating the black rail when it's trying to find refuge. And I have a colleague at UC Santa Cruz, Bruce Lyons, who took some wonderful pictures of it a year ago when we had big king tides. So it does happen. I don't think it's like the main reason why black rails have become rare, but it probably contributes to their rarity in some places. Now, Morro Bay, I think if the habitat is there, that there's a chance to bring the birds back. That they may also likely to turn up and colonize it at some point.
Mm-hmm.
It's been interesting they will use these created wetlands. So there may well be opportunity to create some wetlands in the region nearby that could also act as attractive sites. There's enough topography there. I think the question would be water sources. And that's the interesting thing. So many of our sites in the foothills were accidentally created.
Right.
And we have more wetlands now than there were there in the 1930s and 40s. And we know this by going back and retracing aerial photos in those times. And that's because of the accidental leaks and intentional leaks that occurred, flooding.
Yeah, water is so expensive here that accidental irrigation leaks are frowned on, and even on purpose leaks are frowned on. Go ahead, jump in.
No, that's exactly right. So the accidental leaks have been plugged in some parts of the world. So, for example, along the All-American Canal, down there in Southern California. They plugged a lot of and relined the canal so that the leaks would be less likely to occur. And in doing so, they wiped out a number of sites where black rails were known. And so they had to, as part of mitigation, the water district there had to create black rail sites.
Yeah.
So there can be a problem sometimes by being a little too optimal in our attempts to manage natural resources. Having some waste, in the case for the black rails, actually turned out to be a benefit.
Okay, we have a couple other really good questions. One question to follow up on that is, how about reclaimed non-potable water from sewer systems? Can we, get some of that back into the water table through a surface leak that create wetland?
That's an interesting idea. I think in some regions that probably could work.
Okay.
There's in the foothills there, a lot of the old timers talk about crack water. Okay, I'm not talking about drugs, although there's been quite an increase in pot growing in the region. But I am talking about water that just kind of goes down in the cracks and comes out somewhere else.
Mm-hmm.
Bubbling up in a spring in somebody else's property somewhere.
Mm-hmm.
And so crack water like that, if there are good ways to sort of figure out where that water would go that you injected, or that you could work with the reusable wastewater in a way, purposeful way to create marshes, I think you could probably be attractive places for the rails.
Good.
And I think it's one of the success stories that we have had in wetlands, which have generally been kind of difficult to restore.
Yeah. Good. A couple more good questions because we're heading towards the end here. You talked about some bandings, so I'd like to know if you have any recovered bands other than the turbine. And the other thing is, somebody asked, how about GPS trackers? I know rails are a little tiny, but can we see them, moving around San Francisco Bay with a GPS tracker? Or we're going to have Mary Whitfield on from the Southern Sierra Research Station about MODIS. Maybe there's something we can do with MODIS tags. Anything you can say about tags, bands, trackers?
Yeah. No, we only had that one band recovery, and it happened to be the bird that I took my 12-year-old son with me to rail camp for the week to help dad, and it happened to be the one that he banded. They got whacked and came back to us 3 months later. We have experimented, and others too have put on transmitters on black rails. More the standard VHFs, not the satellite kinds, which aren't small enough yet to be able to do anything with them. I mean, this is only it's a very small bird. The challenge is they spend so much of their time underneath the vegetation that the antennas and stuff, it can get caught up. They don't broadcast very far because the vegetation itself pushes it down. So it's a challenging to work with those kinds of tags. The MODIS tags might tell us when they left a marsh, but we'd have to, in the foothills where the marshes are so diffuse and so small, it wouldn't work to track them. But yeah, maybe you'd get some returns in the Bay Area. It's just those marshes are so big, and I don't think it would be practical yet to use that kind of a tag. So that's why we use the genetic markers. They're giving us that information. We had no idea when we catch birds who was related to who.
Right. Ancestry.com for the black rail family.
You got it.
Okay. Steve, we really, really appreciate your time and your expertise. We just can't believe we're so lucky to hear some incredible science from guys like you and other people that are coming up. Thank you so much for your time. We really, really appreciate it. Now, if people have more questions for Steve, you can just Google him, or you can write to us and we'll forward along questions to him. And that's true for all of our presenters. So we've got some other things coming up, and this is I think that's one too far, Bob. I think we're on Steve Schubert's next. But I just wanted to let you know about a couple things. See on this final screen, there's some QR codes. If you'd like to make a donation and support the possibility of having an in-person festival next year, hold your iPhone or Android up to one of those QR codes and make a donation. A couple bucks would be great. But if you want to go over $300, use the PayPal one, not the Venmo one, which has a limit. And if you just don't know how to do any of that, a check and a stamp and envelope would do it. Thanks very much. So here's what's coming up next. Just a quick little preview. Right after this, at the top of the hour, we're going to have Steve Schubert talking about peregrine falcons of Mora Rock. And you know what? He wrote a book called The Peregrine Falcons of Mora Rock. So that should be interesting. Although he is a little remote and there's a little bit delay in his voice to video, but it's going to be interesting program. After that, we have Brian Sullivan's going to come on, talk about the cutting edge of bird science. And then the final keynote tonight will be John Muir Laws. Looking forward to hearing him at both 5 and 6 o'clock. So thanks everybody for coming. Donate if you can. Share with all your friends. You know, I don't remember how many people were here today, about 100 folks at this one, which is more than would have been at the one in person. And so we're getting the word out, but that means there's 900 seats available. So if you can all go on social media, because we have 1,000 seats at this Zoom talk, go on social media, share with your friends, get everybody here. If they're not outside birding, they should be sitting down watching this with us. Again, thanks, Steve. Appreciate your expertise. It was amazing. I'm smarter now, and I've got a new appreciation for black rails. That little clip at the very end, that little teeny tiny view is probably the best view anybody will ever get of a black rail.
That's a real superhighway right there.
Thanks a lot. We're going to shut this program down, and everybody log back in the top of the hour. Go get a snack, and we'll see you in a couple minutes. Bye-bye, everyone.